ఇప్పుడు ఎస్ వస్తుంది. Good evening, students, audience. Welcome to Physics Cartoon Camera. And today we are continuing the chapter Magnetic Effect of Electric Current. So once we can review that what we completed in last two classes. Current carrying conductor in a straight line. Magnetic field lines we notice through Maxwell right hand thumb rule. Again, current carrying conductor in a loop line. Yes, we have noticed if current direction changes, magnetic field direction also changing. That we studied. Later we studied about solenoid. So solenoid definition we have studied, and the magnetic field lines while using clockwise rule how to calculate we have studied. Then further we studied about the force concept. Okay, the force concept, again Fleming left hand rule we have studied, and why the rod got displaced. Yes, Fleming left hand rule we studied yesterday. And coming with the help of Fleming left hand rule, from electrical energy to mechanical energy, generally we are observing in motors. So how that motor is constructed, what is the work function of motor, what is the basic principle of motor, and what is electric motor. So you can see in this picture there is horseshoe magnet, north south poles, and there is an armature connected to battery, what we are observing in this diagram. So what is electric motor? An electric motor is a device which converts electrical energy into mechanical energy. Okay, the student has to write the answer. Electric motor is a device which converts electrical energy into mechanical energy. Yes, now current is flowing through the battery to split rings. In details we are studying, but what is principle of electric motor? Electric motor utilizes the magnetic effect of current. A motor works on the principle that when a rectangular coil placed in a magnetic field and current is passed through it, a force acts on the coil which rotates it continuously. So this is the principle of motor. Okay, electric motor utilizes the magnet effect of electric current. A motor works on the principle that when a rectangular coil is placed in a magnetic field and current passes through it, force acts on a coil which rotates continuously, which means electrical energy we have given, mechanical energy we got it. We will see there is clearly, see this picture, A, B, C, D is a armature. This armature we connected to X, Y. X, Y are the brushes and split rings P and Q. Then these split rings connected to battery terminals through closer switch. So what happens now? You know that rectangular coil ABCD insulated copper wire, the coil is placed between the two poles of a magnetic field, that is north and south. The armature is AB and CD are the arms of armature are perpendicular to the direction of the magnetic field. So if the magnetic field is like this, we placed perpendicularly. The ends of the coil are connected to two halves P and Q of split rings. Thus, the coil rotates anti-clockwise. At half rotation, Q makes contact. Here there is a Q of split ring. Make the contact with the brush X and P with the Y. Therefore, the current in the coil gets reversed. So once you can see, a device that reverses the direction of flow of current is called commutator. Here, split rings act as commutators. The reversing of the current is repeated after each half rotation, due to which there is a continuous rotation of the coil and to the axial. Now, current in the coil ABCD enters from the source battery through conducting brush X and flows back to the battery through brush Y. On applying Fleming left hand rule for the direction of force on a current carrying conductor in a magnetic field, we find that the force acting on arm AB pushes it downwards, while the force acting on the arm CD pushes it upwards. Okay, so AB and CD, which is pushes up. Now next subtopic, electromagnetic induction. So what is electromagnetic induction? You can see that there is a wire coil, normally coil, copper coil. Both the ends we connected to galvanometer. Simply galvanometer. What is galvanometer? Generally students will ask a question. Galvanometer also we can able to find electric current. A small fluctuations of electric current we can able to find through galvanometer. But what is ammeter? Ammeter exact value. No fluctuations we can find out. So galvanometer we connected. Now wire coil, both the ends we connected to galvanometer. Take a bar magnet, put inside of the coil. You keep on put inside of the coil exactly through axis. So we notice that there is galvanometer under deflections. So what's happening? Why that galvanometer is under the deflection? The production of electricity from magnetism is called electromagnetic induction. Okay. Again repeating. The production of electricity from magnetism is called electromagnetic induction. Now, take a coil of wire AB having a large number of turns. Connect the ends of the coil to galvanometer. Take a strong bar magnet and move it north pole towards the end B of the coil. So what happens? Once the bar magnet keep on we are introducing, mechanically we are doing work. Finally, galvanometer needle is deflecting, so electrical energy we got it. There is a momentary deflection in the needle of the galvanometer. Say to that, this indicates the presence of a current in the coil AB. The deflection becomes zero, the momentum of the motion of the magnet stops. Now, withdraw the north pole of a magnet away from the coil. Now, the galvanometer is deflected towards the left, showing that the current is now set up in the direction of opposite to the first. So keep on, it will be alternate. Place the magnet stationary at a point near the coil. Keep its north pole towards the end B of the coil. We see that galvanometer needle deflects towards the right when the coil is moved towards the north pole of a magnet. Similarly, the needle moves towards left when the coil is moved away. When the coil is kept stationary with respect to magnet, the deflection of the galvanometer drops to zero. What we can conclude from here? We will see that it can be observed that when the north pole of a magnet is brought near the end B of the coil, there is deflection in the galvanometer. If south pole moves towards the end B of the coil, the deflection would just stop the previous case. When the coil and the magnet are both stationary, there is no deflection in the galvanometer. Thus, it can be concluded that motion of a magnet with respect to coil produces an induced potential difference, which sets up an induced current in the coil. Can you answer this question? The phenomenon of electromagnetic induction is option A, the process of charging a body. Option B, the process of generating magnetic field due to current passing through a coil. Option C, producing induced current in the coil due to relative motion between a magnet and the coil. Option D, the process of rotating a coil of an electric motor. Okay. The right answer is producing induced current in a coil due to relative motion between magnet and the coil. Next, but how to determine the direction of a current in the circuit? Yes, current we are getting, but how to determine the direction of current? For that, Fleming right hand rule. Yes, I guess audience were all on live. You can answer any question to me. You can answer any question to me. Any questions? Yes, any questions from the audience? We can see that. I guess no questions. Yes, we can continue. Fleming's left hand rule for the direction of induced current. Okay, while taking the right hand, the center finger, index finger and thumb finger, three also mutually perpendicular direction. Now center finger indicates current direction, index finger will indicate magnetic field direction, and the thumb finger will indicate motion direction. Okay. Now according to Fleming right hand rule, hold the thumb, the forefinger and the center finger of your right hand at the right angles to one another. Adjust your hand in such a way that forefinger points in the direction of magnetic field and the thumb point which is direction of motion of a conductor, then the direction of the center finger points the induced current direction. As a similar way, the left hand rule, right hand rule, the directions of the thumb finger, magnetic field and center finger and physical parameters are the same. But right hand rule, we are identifying the induced current. From the left hand rule, we are identifying the force. So based on this, electric generator. So what is electric generator? The electric generator converts mechanical energy into electrical energy. So electric motor, electrical energy into mechanical energy, quite opposite here. Electric generator converts mechanical energy into electrical energy. Now what is the principle of electric generator? The electric generator works on the principle that when a straight conductor is moved in a magnetic field, then the current is induced in a conductor. Okay. An electric generator consists of a rotating rectangular coil ABCD placed between the two poles of a permanent magnet. The two ends of this coil are connected to the rings R1 and R2. The two conducting stationary brushes B1 and B2 are kept pressed separately on the rings R1 and R2 respectively. The two rings R1 and R2 are internally attached to an axle. Okay. When the axle attached to the rings is rotated such that the arms AB moves up in the magnetic field produced by the permanent magnet, by applying Fleming's left-hand rule, the induced current are set up in these arms along the direction of AB and CD. Thus, an induced current flows in the direction of ABCD. If there are larger number of turns in the coil, the current generated in each turn adds up to a given a large current through a coil. This means that the current in the external circuit flows from B2 to B1. After half a rotation, arm CD starts moving up and AB moving down. As a result, the direction of induced currents in the both arms change, giving rise to the net induced current in the direction of DCBA, which is ulta. The current in the external circuit flows from B1 to B2 now. Thus, after every half rotation, the polarity of the current in the respective arms changes. Now, such current will change the direction after equal intervals of time is called an alternate current. This device is called AC generator. To get the direct current, a split rings type commutators must be used. With this arrangement, one brush is set all times in contact with the arm moving up in the field, while the other is in contact with the arms moving down. So simultaneously it will be rotates. So we have seen the working of split rings commutators in the case of electric motor. Thus the unidirectional current is produced. If it is unidirectional, the generator is called as a DC generator. Okay. The difference between the direct and alternating currents is that direct current always flows in one direction, whereas the alternating current reverts its direction periodically. In India, AC changes direction after every 1/100 seconds, that is the frequency of AC 50 Hz. Yes, there is a question. A rectangular coil of copper wires is rotated in a magnetic field. The direction of the induced current changes once in each 2 revolution, 1 revolution, half revolution, 1/4 revolution. Each and half revolution we have studied. The essential difference between AC generator and a DC generator is that option A, AC generator has the electromagnet while the DC generator has the permanent magnet. Option B, DC generator will generate a higher voltage. Option C, AC generator will generate a higher voltage. Option D, AC generator has slip rings while the DC generator has commutators. The right answer is option D. AC generator has slip rings and the DC generator has commutators. So next, domestic electric circuits. This current year, which is there in the syllabus of cbse. Now what kind of matter it is? Electricity is generated at lower power stations and it is brought to our homes through main supply supported through overhead electric poles or by underground cables. One of these wires with red insulation is always live wire. Another wire with the black insulation is called neutral wire. In India, the potential difference between these two is 220 volts. There is no harm in touching neutral wire, but you will get an electric shock if you touch with the live wire. At the meter board in the house, these wires passes into an electricity meter through a main fuse. The two wires coming out of the meter are connected to main switch. Usually, there are two separate circuits in a house. The lighting circuit for the running low power rating devices with 5 amperes fuse and the power circuit of the running high power devices with 15 amperes of the fuse. The earth wire, which has insulation of green color, is usually connected to metal plate deep in the earth. This is used as safety measure, especially for those with metallic body. Due to earthing, the metal casing of the appliances will now always remains at zero potential of the earth. Now you can see there is a live wire and neutral wire we connected to fuse, then connected to energy meter to distribution box. So earth wire directly from the earth to each and every the big pinhole of the domestic circuit. So the potential difference here 220 volts. Okay, this is the schematic diagram of common domestic circuits. Electric fuse is an important component of all domestic circuits. A fuse in a circuit prevents damage to the appliances and circuit due to overloading. In order that each appliances have equal potential difference, they are connected parallel to each other. Also, connecting in parallel is beneficial because if a fault occurs in one circuit, its fuse will melt having the other circuit in operation. So you can see that there is at house how we are doing electric circuits. Short circuit and overloading. Most important Thomas question. Short circuit and overloading. Short circuit occurs when live wires and neutral wire comes in a direct contact with each other. Due to this, current in the circuit increases abruptly. The current flowing in a circuit at a particular time may increase if too many electrical appliances of the high power rating are switched on the same time. This is called as overloading. Okay. Now electric fuse. The use of an electric fuse prevents the electric circuit and the appliances from the possible damage by stopping the flow of unduly high electric current. A fuse is connected in series in electric circuit. The Joule's heating takes place in a fuse melts which breaks the circuit. There is a question. At the time of short circuit, what happens? Option A, reduces substantially. Option B, does not change. Option C, increase heavily. Option D, vary continuously. It increases heavily. Next, state whether the following statements are true or false. An electric motor converts mechanical energy into electrical energy. Electric motor, mechanical energy into electrical energy. Obviously it is false. Electrical energy into mechanical energy. Fan has to rotate. Okay. An electric generator works on the principle of electromagnetic induction. Yes. Next, the field at the center of a long circular coil carrying current will be the parallel straight lines. Yes, center will be the straight lines in a loop wire, what we understood. A wire with a green insulation is usual as a live wire and electric supply. No, false. Green insulation only earthing wire, live wire is red wire. Any queries, audience? In the description there is an email. You can able to ask the questions. Any questions still? Yes, I guess probably it is done this chapter. And again tomorrow we'll meet with question and answers and reasoning questions. We'll conclude this chapter by today. Thank you so much. Bye for the day. Good night. Jai Hind.